Partial fractions is going to be a theme all the way through this section, through this chapter. It's going to come up a lot. We're going to do partial fractions once today, and then you are going to be responsible for refiguring out how to do it. I'm just going to jump to the end of partial fractions, but they are all written out in my notes on Moodle if you want to see them. Okay, so we're going to do it once as a refresher, and then after this, it's up to you. So here's what we've got. 2s minus 3 over that factors, s minus 3, s plus 2. And so then I need to do a over s minus 3 plus b over s minus 2. Partial fractions, doing an splitting up with partial fractions. Multiplying both sides, 2s minus 3 is a times s plus 2 plus b times s minus 3. Splitting up, partial fractions. And then I want to try convenient values of s. So we can use s equals negative 2. That's a convenient value of s. That will give me negative 7 equals a times 0 plus b times negative 5. And so therefore b equals 7/5, partial fractions. And if s equals 3, that will give me 3 equals a times 5 plus b times 0. And so a equals 3/5. Daniel has a question, and I can only see you because you happen to be on my screen, so remember to do a virtual hand raise if you have a question. Go ahead, Daniel.
Wait, is it negative 9 for s equals negative 2?
S equals negative 2. Nope, so negative 4 here, and then minus 3 gives you negative 7.
Oh, duh, yeah.
Good?
Yeah, that makes sense. I can do math.
That's okay. I have made so very many mistakes over the last week that it's not even funny. So making mistakes is totally fine. All right, so here's where I'm at. Capital X of s is, let's get my a and my b in the right spot, 3/5 over s minus 3 plus 7/5 over s plus 2. That's my capital X of s. 3/5 over s minus 3 plus 7/5 over s plus 2. Now, front of your book, please, or table, or wherever it is. Go look and see if you can find these for inverse transforms. The 3/5 and the 7/5 can totally pull out in front, so don't worry about the numerator. The 3/5 and the 7/5 can totally pull out in front. So you are looking for 1 over s minus 3 and 1 over s plus 2. And I'm going to have you look, and then I'm going to see all of you, and you're going to make a thumbs up or thumbs down if you find those in the front part of your book. Okay. Are we finding those? Thumbs up, thumbs down. Are we finding those in the front part of the book? Yes, I'm getting some thumbs up. Cool. So here is where I'm going to end with. Don't put equals. This is not equal to little x of t. An arrow is fine and equals is not. Little x of t is then 3/5 e to the negative 3t plus 7/5 e to the negative 2t. And that is my answer. Let's see if I can do better at boxing it. Ooh, getting better at drawing boxes. There you go. Stuart.
Wouldn't it be e to the 2t positive 2?
Yes, it would. Thank you for that. Let's go with e to the positive 2t instead of the negative 2t. And actually, let's just erase that because that's horribly, oh, and I erased the 2. Okay. Thank you. Okay, I just had 3 people raise their hand, and I don't know who all that was. Stuart again, or is that still from the previous one?
That was an old one, sorry.
Okay, somebody else has their hand raised. Let's see. Grant.
Where is it in the front table exactly? Is it? Oh wait, no, I just found it.
You got it? You sure?
Yeah.
Okay, and then Bethany.
Yeah, I think the negative should be on the 2.
Do I want the negative on the 2? Did I do it backwards? I bet I did do it backwards. Yes, because the inverse transform, sorry, thank you. Inverse transform of 1 over s minus a is e to the a t, inverse transform of that. So I want the negative on the 2 and not on the 3. Can we erase? Oh, come on, oops, and I erased too much. So desperately want a chalkboard. 3/5 e to the 3t plus 7/5 e to the negative 2t. Okay, that should be right. And lovely. Okay, so that's the process. Let's talk back through this example and then we're gonna do another one. So here we go, here's what we did. First step, differential equation, Laplace transform. Took the Laplace transform on both sides. Second step, solve for capital X of s using some algebra. Third step, find an inverse Laplace transform, and a lot of times this is going to happen by partial fractions, a lot. And step number 3 is definitely the hard step at this point in time. Okay, let's do a quick stop share before we do the next example. Anything for questions at this point with that process? Good? Okay, here's the beauty of this. I'm gonna do a non-homogeneous equation at this point in time. Do you remember back in chapter 2 when we did non-homogeneous equations and we had to come up with the associated homogeneous equation, and then we had to find a solution to that, general or particular, and then we had to find another solution, and then we had to add them together, and we had to find the coefficients and all that jazz? Yeah, you don't have to do that with Laplace transforms. It's nice. The non-homogeneous and homogeneous cases work exactly the same way. So let me show you one of those. Here we go. For example, let's say we have this one. X double prime plus x equals cosine of 3t. And I need initial conditions. X naught is equal to 1 and x naught prime is equal to 0. X double prime plus x is cosine of 3t. X naught is 1 and x naught prime is 0. We'll do the steps one more time, this time labeled, and then after that I won't. So first of all, Laplace transforms. This gives me s squared, capital X of s, minus 1s minus 0. That's my first transform of x double prime. There is no x prime, so I don't have to worry about that. And then we've got plus capital X of s. So that's the transform of the left-hand side of the equation. Front part of your book, if you look for the transform for cosine of 3t, that's going to be s over s squared plus 9. So again, front part of your book, transform for cosine of 3t, s over s squared plus 9. Front part of your book. All right, step number 2, solve for capital X of s. Doing a little bit of algebra, I am going to get capital X of s is s over s squared plus 9 plus s, and then all of that is divided by s squared plus 1. If you don't see that, write out the algebra. I'm going to trust that you see that and that you can write out the algebra. If you don't see that, write out the algebra for where that's coming from. That's horrible. There's no possible way we're going to find an inverse transform of that. So we're going to need to do a little bit of algebra first. If we find a common denominator in the top, we're going to have s plus s times s squared plus 9 all over s squared plus 9. And then all of that is still over s squared plus 1. You almost always want to find a common denominator. That's going to make your life so much easier at this point in time. And then I'm going to distribute through the top and make one single denominator. So my denominator is s squared plus 9, s squared plus 1. And then my numerator, rearranging terms a little bit, is s cubed plus 10s. So s cubed plus 10s in the numerator, s squared plus 9, s squared plus 1 in the denominator. These problems are heavy on algebra. They are heavy on algebra and they're heavy on the partial fractions as well. The actual differential equations in these problems really isn't too bad, honestly. Okay, we're ready for step number 3, which is solve for, or do an inverse Laplace transform. So for step number 3, inverse Laplace transform. Here's where I'm going to jump. So capital X of S, if I do partial fractions, assuming that my notes are correct, and if we get the wrong answers, then just know your numerators are off, but I'm pretty sure this is right. 9/8 over 9/8 S over S squared plus 1 minus 1/8 S over S squared plus 9. Partial fractions, the details are written out in my notes. You should be able to go through and do the details of partial fractions, but I don't want to spend time on that in this differential equations class because you should know how to do that already. So 9/8 S over S squared plus 1 minus 1/8 S over S squared plus 9. Last step. Front of your book, chart. Go ahead, take a look at the chart and see if you can come up with your little x of t in this case. Figure out what it looks like, come up with your little x of t. What's your inverse transform in this case? Take a minute, see if you can figure that one out. Looking at the front of your book. And again, the 9/8 can stay out in front and the minus 1/8 can stay out in front. You're going to get very familiar with the chart in the front of your book. Very familiar with the chart in the front of your book. I get 9/8 cosine of t minus 1/8 cosine of 3t. 9/8 cosine of t minus 1/8 cosine of 3t. And that is my answer, and I am going to box it. Stuart.
Yeah, so I was just wondering, the ones beneath those where it's like cosine HKT.
Yes, that is hyperbolic sine and hyperbolic cosine, and I promise we are never going to use those.
Okay, great.
They come up in the calculus book a little bit, and they get used for some things, but they're not necessarily what I want to focus on. So that it's hyperbolic sine and hyperbolic cosine. That's what it is.
Got it.
Okay. Anybody else? Other questions on that one? Okay. Let me get all of you back together here. Oops, that was not what I wanted to do. Let me get all of you back together here. There we go. All right, how we doing? Thumbs up, thumbs down. How we doing? How's it going? Making sense? Good? Okay. I'm going to talk about one more thing with this problem. We're going to go back a slide. So I really want to point this out. Notice that this one was a non-homogeneous equation, right? This was a non-homogeneous equation, cosine of 3t, but we treated the problem exactly the same way. That is why this is so super cool. You don't have to worry about whether you have a homogeneous or non-homogeneous equation. It does not make a difference. You treat them exactly the same way. So that's why this is really, really nice. Okay, I'm gonna give you one and I'm gonna put you into breakout rooms for you guys to try this. So here's my next one, and we're gonna go back to non-homogeneous. Here's my example. X double prime plus 4x prime plus 3x equals 1. X naught is 0, and x naught prime is also 0. X double prime plus 4x prime plus 3x equals 1. X naught and x naught prime are both 0. X double prime plus 4x prime plus 3x equals 1. X naught is 0 and x naught prime is 0. Okay, let's do breakout rooms. I think we're gonna put 3 or 4 of you in a room. We're doing this automatically. Here we go. You should have an invite.